Audio Jungle. Audio Jungle. Audio Jungle. Audio. Audio Jungle.
Hello everyone, welcome back to Basic Physics, and my name is Aaron. Today we're going to get into a new topic called vectors and scalars. Have you heard about vectors? Do you know what a vector is? Or what is a scalar? In the study of motion, especially two-dimensional motion, it is necessary to identify vector and scalar quantities. Using simple terminology, vector quantity shows both magnitude and direction of motion, whereas scalar quantity only shows the magnitude. Let me give you an example. For example, if I tell you today is 27 degrees Celsius, is this vector or scalar? Based from this given example, you would see that 27 degrees Celsius only gives you the magnitude of the temperature with no reference to any direction. So we would say that 27 degrees is a scalar quantity. What about velocity? Is velocity a vector or a scalar? Got it right, it's velocity. Velocity is vector quantity. So why is velocity a vector quantity? Well, simply put, velocity would take note of not only the magnitude of the speed, but also the direction. So that's why we would say that velocity, acceleration are both vector quantities. So which measurement can be categorized as a vector? Which ones are scalar, as I mentioned a while ago? Now let's put this into another example. Let's check. When your GPS tells you to drive north 500 meters, then turn left, this is a vector. And during a baseball practice, if you're asked to throw a ball to the right, that is also a vector. However, calories burned during exercise requires no direction. You just burn and burn without any direction. Therefore, it is scalar quantity. During winter, when the temperature reaches -2 degrees Celsius, but the negative value does not denote any direction. So just the actual temperature give us a scalar value. Mass and volume are also scalar quantities. A vector quantity is usually represented with an arrow over the letter, like for example letter A, with an arrow on top. Ordinary arithmetic operations are used for scalar quantities. Mathematical operations can also be performed on vectors, but because the direction must be considered, we must use the head to tail method as well as a Pythagorean theorem. And also, you'd also be needing the trigonometric functions. When we are solving these problems, it becomes a bit more challenging, but still manageable. So now, what is the head-to-tail method? The head-to-tail method simply means that when I add vector A to vector B, I draw vector B at the tip of vector A, like this. If I subtract vector B from vector A, the diagram would look like this. Now, when I want to go visit a friend and travel 4 kilometers east from my house, then turn north and travel another 3 kilometers before arriving at my destination, what is my resultant displacement? Since we are dealing with vector quantities, the result is not simply adding 4 kilometers and 3 kilometers. How do we solve for the resultant displacement? First, let us designate vector A as 4 kilometers east, vector B as 3 kilometers north, and the resultant displacement as vector R. Next, we draw the figure for this problem. The figure that we have drawn is a right triangle. Yes, it's a right triangle, and if we have right triangles, then what can we use? Yes, we can use the Pythagorean theorem. We could use this to solve for the resultant displacement, which is 5 kilometers, not 4 kilometers plus 3 kilometers equals 7 kilometers. So what we have here is r squared equals a squared plus b squared, wherein we would have r squared equals 4 squared plus 3 squared, with result to r squared is equal to 25, and we take the square root of both sides. The resultant would be 5 kilometers. But then, this is one method. Could we use another method? Yes, we can. We could use trigonometric functions when we solve the angle. So tangent theta is equal to 4 kilometers divided by 3 kilometers, that would be equal to 1.5. The theta, or the angle, is 53 degrees Celsius. From these calculations, the magnitude and direction of my displacement when I visit my friend is 5 kilometers at 53 degrees north of east.